Okay, today I'm going to do a little bit of some quick work, kind of a review of all the circle geometry concepts that have been covered thus far. The very first thing I want to start with is the relationship between central and inscribed angles. So real quick review. The central angle in this case is angle ACB. From here down to the B. Whereas the inscribed angle, by definition, has all its endpoints on the circumference of the circle. That's angle ADB. First thing we want to notice about angle ACB and angle ADB is that they are both subtended by the same arc. That means if you go directly opposite the angle, the chunk of arc you land on has its endpoint the same as the angle. Angle ACD comes straight across and we notice the same thing. That chunk of arc between A and B is the same arc. Therefore, a very special relationship exists between these. We know angle ACB is equal to 2 times that of angle ADB. Quite simply because this is a rule of central and inscribed angles. Likewise, angle ADB, I apologize. Angle ADB is half that of angle ACB. Divided by 2. Right? Because both angles are subtended by the same arc. To show this mathematically, let's say that we knew angle ACB. Let's say we knew this was 50 degrees. Therefore, we would jump to angle ADB is equal to half of angle ACB, which in this case is 50 degrees divided by 2, which is equal to 25 degrees. Because both angles are subtended by the same arc. Had I have known already angle ADB was 25, let's make the assumption I didn't know angle ACB, then I just say angle ACB is equal to 2 times angle ADB, angle ADB, or the inscribed angle, which is equal to 2 times 25 degrees, which equals 50 degrees. Because both angles are subtended by the same arc. If I wanted to draw a second inscribed angle, let's do it in purple. As long as that inscribed angle is still subtended by the same arc, this AB, it would still be equal to the other inscribed angle, because it has to be half of this central angle here. If this was angle E, we could say angle ADB equals angle AEB because they are both subtended by the same arc. A pretty special case that we might want to take a minute to look at, this one here. Get rid of that. So here we have an inscribed angle. This thing's in my way. Right, here we have an inscribed angle, angle AD to B. Angle ADB. So to try and figure out the measure of this angle, simply look across and see, yep, it is subtended by this big arc, angle AB. What's more, not only is it subtended by that big arc, it's actually subtended by the diameter of the circle. So the measure of angle ACB, because it's a flat line, is 180 degrees. That angle is said to be subtended if I go from the C, the center of the angle, by this big hemiarc down here, or this big hemiarc up here. Either one is fine. And we recognize they're a hemiarc because they account for half of the circle. Let me go around. I'm half of the circle. I'm going to pick the bottom one because I notice it is subtended by the same arc as my angle, angle ADB. And I know something special about central and inscribed angles subtended by the same arc. Angle ADB is equal to angle ACB divided by 2. Because both angles are subtended by the same arc. Therefore, angle ADB is equal to 180 degrees divided by 2, which is equal to 90 degrees. Bing, bang, boom, done. Now to look at perpendicularly bisecting, in this case, a line. Quite simply what it means, if it's a perpendicularly bisected, the word perpendicular means it's at 90 degrees. And to bisect means cut in half. Easiest way to do this, maybe not the easiest, but the method we're going to use is to use this protractor here. Or sorry, this compass. Go to there. Perfect. Now because this is digital, it doesn't slide quite perfectly. I'll get as close as I can. Right, so simply to perpendicularly bisect, just draw a half circle like that. Right, with the ends of your compass obviously on the end of your line. Flip it around. Line up the points of your compass, the end of your line. Draw a second half circle. And then where these points intersect, simply draw a line between them. Not quite perfect, but pretty close for a computer simulation. At this point here, I now have a perpendicular bisector. So this is 90 degrees, and these two chunks of line are the same length. To find the center of a circle, I simply use perpendicular bisectors. Step 1, draw two chords. You can actually write that. Step 1, we don't need to write that. Draw two chords. Oh. Step 2, perpendicularly bisect each of the chords. We can do that with our compass. Again, the ends on our lines. Rotate this a hair. Bring that in just a bit. There we go. Line like that, a little further. Seriously. Flip it around. Do the same on the other end. And bring it over to my other line. The chord, I should say, it's not just a line, it is technically a chord because it has endpoints on the circle. Same thing here. Flip it end for end, slide it down. And do the same thing. And when I connect my lines, I'm going to see that they do pass through approximately the center of my circle. If I was doing this on paper where it's a little easier to be accurate, they would pass exactly through my circle, which they actually kind of did. That's how you find the exact center of a circle. This is a very classic problem that pops up all the time, finding the depth of water in a pipe. So here's the question that's given to us. A pipe of water is 5 centimeters across. That means it has a diameter of 5 centimeters. If a quart of water is 6 centimeters wide across the pipe, how deep is the water? I apologize, this should have said 10 centimeters across. Right? If the diameter of the pipe was only 5 and the water is 6 centimeters across, it's too wide. So a pipe of water is 5 centimeters across. In this case, a pipe of water is 10 centimeters across. So I can simply draw a line across my pipe, 10 centimeters long. Then I have a depth of water somewhere. It's going to be 6 centimeters across. Let's draw it. Ooh, it's going to go here. That is 6 centimeters across. We want to find the depth of the water, which is this missing component here. So we start filling in what we do know. Well, I can drop a perpendicular bisector straight down to that point there. Let's call this point E. I'm going to label the ends of my water level A and B. And this point right here where they intersect is actually a perpendicular bisector, that point D. So the length of DB, this portion here, is equal to AB divided by 2, which equals 6 centimeters divided by 2, which equals 3 centimeters, because the line is perpendicularly bisect. Is perpendicularly bisected. So I'm on my way to finding the depth of my water. I now know this chunk of cord here is only 3 centimeters. I don't know this piece here, but I can construct a right angle triangle because I can figure out the radius. Diameter is 10, radius must be 5 centimeters. Now I just label the sides of my triangle and do some solving. 5, okay, the 5 here versus the 3. Right? 5 is the longest side of my triangle. So in the formula, a squared plus b squared equals c squared. 5 must be c. Then a or b, it doesn't matter. I'm going to call this side a, this side b. So rearranging, recognizing that I'm looking for the missing component of b. Subtract a squared from both sides. B squared is equal to c squared minus the a squared. Means b squared equals 5 squared minus 3 squared. B squared equals 25 minus 9. B squared is equal to 25 minus 9 is 16. Once I get to this stage, I'm going to take the square root of both sides to do away with b squared. Side b equals 4 centimeters. Oh, I apologize, I labeled my triangle wrong. This was my A side, this was my B side then. It doesn't change anything, right? Just the fact that I was looking for side B and I found side A. Okay. So sadly my drawing isn't very well to scale, but eventually what we found out here was that this side here is 4 centimeters. Keeping in mind this was the radius. So the full length down to here was 5. If this chunk here was 4, this length must be 1. So the depth of the water, which I'll do in black, is the radius minus side B, which is 5 centimeters minus 1 centimeter, which is 4 centimeters total.